Welcome back. Today we're doing two-step equations with variables on both sides. Now, these particular problems that we are working with today, we will need to use the distributive property to solve them, because this says 6 times an unknown number plus 3 is going to be equal to or the same amount as 2 times 4 times an unknown number plus or minus 1, excuse me. So in order to get rid of these parentheses, the easiest way to do this is to multiply everything inside these parentheses. So if I utilize the distributive property, I can take 6 and multiply it times x. I don't know what x is, but I know that whenever I multiply 6 times x, I will be left with 6x's. Now, I need to distribute to everything inside the parentheses, not just my variable. So I need to take 6 and multiply it times 3, or in this case, a positive 3, if you will. So 6 times that positive 3 is going to give me a positive 18. So I'm going to write positive or plus 18. So now that I have the left side distributed, I need to distribute the right side as well. 2 times 4x. Well, we know that 2 times 4 is 8. And then, of course, that is 8 times x, which we don't know what x is. So we will just say 8x. Now we need to distribute here as well. I have 2 times minus 1, or negative 1, however you want to say it. 2 times a negative 1, well, that's going to be simple. That's a negative 2. Now that I have gotten rid of my parentheses and moved them out of the way, I can solve this like a standard two-step equation. I need to get all of my variables on one side of the equal sign, and I need to get all of my numbers on the other side. I personally like working with positive x's. So if I look at this and I say, hey, I want to work with positive x's, I can either subtract 6x from the left or subtract 8x from the right. But if I subtract 8x from the right, I will be left with a negative x on the left. And I don't want to do that. So I'm going to subtract 6x's from the left. So here, let's do that in another color, as a matter of fact. Let's go ahead and switch that to blue. That way we can show the next step. I'm going to subtract 6x from both sides. Once I subtract 6x from the left, I'm going to go ahead and box this in here, because 6x minus 6x, well, that just adds up to 0, right? Because if I have something and I take that same amount of something away, there's nothing left. So technically, I'm left with 0 plus 18. Let me fix that plus sign there. Now, I know most of the time we don't write 0 plus something because it's the same thing. So let's just not even write it this time either. Let's get rid of that 0 plus. How about if we just put 18? So I've got 18 on the right side. On the left side, I'm going to box these in, and I have 8x minus 6x. If I have 8 of something and I take 6 of them away, I still have some of that thing. What do I have? I have 2 of those things, so 2 x's. Now, I did not use this minus 2, so I just need to bring that down, and now I have the same problem again, or a more clarified problem, I guess I should say. I have removed the variables from the left-hand side. But I have not got all of my numbers to the other side. So I need to get rid of this minus 2, because I want all of my numbers on the left side, because I'm putting all my variables on the right side. So how do I get rid of a minus 2? We just do the opposite. We add 2. So let's go ahead and do this one in green. So we're going to add 2 to this side. Now, anytime we are adding a positive and a negative together, if they're the same amount, they're going to add to 0. So this leaves me with 18 is equal to, oh, I'm sorry, I am so sorry. I need to add 2 to the right side. I have to keep this fair. Anytime I add to the right side, I have to add to the left side. If I subtract from the left side, I have to subtract from the right side in order to keep it fair. So I've added 2 on the right side. So now I've added 2 on the left side. 18 plus 2, well, that's 20. So let's go ahead and move this over here to the right-hand side of the screen. So I have 20 is equal to 2x. And the reason I can say 2x is because this 2 has been canceled by the negative 2 and the positive 2. So they've canceled each other out. So now I know that 20 is equal to 2x. Goodness, I apologize. Now you can probably already tell what x is equal to. But if we do this the right way, we are going to divide by the coefficient of x. In this case, our coefficient of x, coefficient is just a fancy word for the number that's stuck or the number that is working with x. So we are going to take our 2 in this case, and we are going to divide by that coefficient, which is 2. But again, anything that I do to one side, I must do to the other. Well, if I have 2 x's and I divide them into 2 different groups, I am only going to have a single x in that group. Now remember, on the left side, I had 20. So if I had 20 and I divided that into 2 groups, again, we have to keep it fair. That means that each x is going to be equal to 10. Let's try another problem like that. How about this one? We're going to need to distribute again. So I'm going to start with red, and I'm going to distribute 2 times 3x. 2 times 3, we know that that's 6. And then we're going to be multiplying times x. But I have to distribute to both or all terms inside the parentheses. So 2 times a positive 5 is going to give me a positive 10. Don't forget my equal sign. On the right-hand side, I have more parentheses that I have to deal with. Let's distribute that as well. Here I have a negative 3 times a negative x. And we remember that a negative times a negative will give us a positive. So negative 3 times negative x is going to be a positive 3x. Now we need to distribute to the other term as well. Right here, what is negative 3 times a positive 10? Well, now we have a negative times a positive. Anytime our signs are different, our answer, if we're multiplying or dividing, we're going to end up with a negative number. Negative 3 times positive 10 is going to equal or create a negative 30. Since we have a variable and a number on the left and a variable and a number on the right, we can take these numbers and we need to get all of our variables to one side and all of our numbers to the other side. So it doesn't matter which way we do it or what number we use first, but I like to work with my x's first. So let's take 3 x's from both sides. If I subtract 3 x's from the right and I subtract 3 x's from the left, I am going to be left with nothing on the right. This positive 3 and negative 3x are going to cancel each other out. On the left-hand side, I have 6 x's minus 3 x's. That is going to leave me with 3 x's. So I have 3 x's. Don't forget my plus 10 because I need that. So plus 10 is equal to a negative 30. So I need to bring that down. And again, that number is negative until we're told, a number is positive unless we're told that it's negative. And here we were told that it's negative. Let me rewrite this problem over here so that we have a little bit more room to work. 3x plus 10 is equal to a negative 30. So if we have a 3x plus 10 is equal to negative 30, we might be able to figure that out. But if we move our numbers to one side, so like that minus 10 or that plus 10, if we wanted to get rid of that, we could get rid of a plus 10 by minusing 10. So whenever we minus 10 here, we have to do it to both sides. Okay, so what is positive 10 and a negative 10 together? That's right, it adds up to 0. We're going to be left with 3x is equal to a negative 30 and a negative 10. That's going to make a negative 40. Okay, and of course, our last step that we need to do is we're going to go ahead and try it in purple here. We need to divide by that special number called a coefficient that is with x. In this case, it's 3. We're going to divide by 3. We're going to divide both sides by 3. And this is going to leave me with a single x. And that single x is going to give us this fraction number here. Okay, so we can, it's a negative number because a negative 40 divided by 3 is going to be a negative number. So we can leave it in either fraction form of negative 40 divided by 3. So there's a fraction that works. Or we can ask the question, how many times does 3 go into 40? So if we ask that question, how many times does 3 go into 40? How many times does 3 go into negative 40? That's going to be 13 times. So we can say that this is also equal to a negative, remember, because negative number and divided by a positive number is going to create a negative number. It's going to go 13 times. And that's true, but it does not go in there completely 13 times. That is going to give us 39 out of 40. Well, we had 40, so we have 1 left over, and we need our denominator, which it still takes 3 pieces to make a whole. So our answer is 13 1/3, or we can always use a negative 40 over 30. Excuse me, a negative 40 over 3. I apologize. All right, so guys, I hope this helps you guys understand two-step equations. I will see you on the next video. Stay safe.